Oh yeah, here.
Continue.
Hold this one,
Okay.
maybe Ryan will pop it.
Don't throw it because it won't go in there.
We've
The
talked
reservoir,
about,
it'll bring it
hello?
down.
We've talked about spontaneous processes. And we talked about two forces in nature that would tend to make something spontaneous. Name one. Manta. Name one force in nature that would tend to make something spontaneous.
The sun. Oh, the sun?
Chuck Norris.
Shut up.
Patrick Swayze.
And so
Okay, you might want to refer back to this second slide of this unit after the title page. First slide. Huh? Nope.
Entropy.
order and
What about entropy?
Oh, order and disorder.
Which way am I going that would tend to make something spontaneous?
Disorder. From order to disorder.
From order to disorder. That's a, when that happens, that would tend to make something spontaneous.
I know another one.
Okay? What's the other trend in nature that would tend to make something spontaneous? Mata? High energy to low energy.
Dang, Gary, you're smart.
Okay?
I want to be
If
like
we have a system and it goes from high energy to low energy, like you have propane, has a lot of potential energy, internal chemical energy. We ignite it, it gives off energy, we get heat from it, and we end up at a lower energy level.
you put flour in one of these.
Okay? That tends to be spontaneous. Why do I keep saying tend?
So this is not perfect.
What is that?
Because it's a probability that.
No. I can have one force in nature that would be tending to make something non-spontaneous, and another force in nature tending to make the same process spontaneous.
Okay. Say again. What was the question?
If our delta H has a negative value, or I guess it would be better to say is less than 0. Is that endothermic or exothermic?
Oh,
That's
exo.
exothermic. So it's giving off energy.
Yeah.
So the system is losing energy.
Correct.
Something with a negative value for delta H would tend to be spontaneous. Okay? The other force in nature was entropy. If delta S is greater than 0, that would tend to be spontaneous because we're increasing in disorder. Okay?
Yes.
Now, in order to know if something is, we want to get rid of that 10. It would tend to be spontaneous. We want to get rid of the 10 and we just want to know, is this process spontaneous or not? In order to know, I have to combine these two things. Because they could be working against each other. Okay? When we combine them, we get Gibbs free energy. Gibbs free energy is basically just the energy available in the universe to do work. Yeah. There's our little equation that combines delta H and delta S. Note that delta S is temperature dependent. Okay, it's temperature dependent because if you think back a little bit ago, we were talking about water. If we're below 0 Celsius, water tends to freeze spontaneously. If we're above 0, say at 40 degrees Celsius, water would melt spontaneously. If it was frozen, it would melt, right? So whether something is spontaneous or not is temperature dependent. So we got temperature, we've got delta H, and we've got delta S. A nice little neat equation, and we solve for Gibbs free energy. Okay? Yes?
I'm assuming when we have to solve for Gibbs free energy that the question will give us the temperature?
You'll have to.
Okay.
All right, if delta G is less than 0, the reaction is spontaneous in the forward direction, meaning as written. You must know this. If you have a negative value for delta G, then it is spontaneous. If delta G is greater than 0, the reaction is non-spontaneous as it's written. The reaction is spontaneous in the reverse direction. If we were to flip it, then it would be spontaneous. Because it's the opposite process.
Repeat it.
Hmm?
You repeat that.
You can read it again. How about I give you an example?
That'll
Yeah,
work.
that works.
If I do that.
Okay. There's the reaction of glucose and oxygen to produce carbon dioxide and water. Happens in every cell of your body. It's a spontaneous process. So Gibbs free energy would have a negative value. If I reverse it, CO2 plus H2O going to C6, H12O6 plus oxygen. This happens in photosynthesis. This is not a spontaneous process. This takes an input of energy from light for plants to do it. Okay? It's the exact reverse reaction. This is spontaneous. This is not. We can force non-spontaneous reactions to occur. It just takes, we have to do work on it. It requires energy. Okay? So if we know something is spontaneous in the forward reaction, we know that the reverse reaction is just the opposite. Does that answer your question?
Somewhat. That's my
If delta G equals 0, then the reaction is at equilibrium. Okay?
So non-spontaneous is when it's bigger than 0, and spontaneous is when it's less than 0.
If delta G is less than 0, it is spontaneous. If delta G is greater than 0, it's not spontaneous. If delta G is 0, you're at equilibrium.
So complicated.
If you're a little bit above 0, then it's not spontaneous.
Yes, Melissa.
But a change in temperature would probably change it. Okay,
Could be that.
that's in your notes. It's kind of confusing. Let's do this. I'm going to write something that works a little bit better. See if you can get it on there. Find a place in your notes to put this. We're going to have 4 quadrants.
No. No more quadrants. We're never doing that.
What was our little equation? Delta G equals
Delta H
delta H
minus T delta S.
delta S. Okay? So we've got delta S on the x-axis, delta H on the y-axis. Here we'll have 0, 0. Is that how you do it in math class?
Yeah.
I think.
They're both 0 here. Okay?
Cool.
Right?
Yeah.
So we're going to deal. How do you number quadrants in math?
1, 2, 3, 4.
One?
No.
1?
2, 3, and a 4.
I haven't had a math class in 30 years.
Today he still learns math.
I knew they were numbered.
Good job.
Wow.
They're numerals though.
Okay. So down here, delta H is negative, right? So anything down here, delta H would tend to be
Not
spontaneous. Anything that would have a negative value for delta H would tend to be spontaneous, right? So in this quadrant, delta H is negative and delta S is positive, right? So delta H would be tending to make it spontaneous, because if delta H was negative, then it's exothermic, that would tend to be spontaneous. If delta S is positive, then chaos is increasing, so that would tend to be spontaneous. So in this quadrant, these would be spontaneous, spontaneous, at any temperature. Write that. Delta H is negative, delta S positive. Both those things would tend to make a reaction spontaneous. So if they're both working in favor of that being spontaneous, you know those will always be spontaneous. And the reverse reaction would always be non-spontaneous. You with me? All right, let's go up here to quadrant 2, they call this one.
Whoa.
Okay, in quadrant 2, delta H is positive and delta S is negative. Nothing there is working to make that spontaneous, is it? So these are non-spontaneous. At any temp. What are you doing with the balloon? It's irritating.
Oh, it's not me.
It was him. That's where all the squeaking was coming from.
Yeah.
My balloon doesn't squeak.
My balloon don't squeak.
You don't.
Any questions on these two quadrants? Okay, now let's look at our formula a little bit, and we're going to figure out these other two quadrants by analyzing the math of the situation.
Okay.
Okay, so let's say we're in this quadrant. We've got delta H is positive, right?
well, both of them positive.
And delta S is positive, right? In order for this to be spontaneous, delta G has to be negative. Yes?
Yeah.
It would work.
It'll work sometimes. This is positive, and then we're subtracting the temperature times the delta S.
Which is positive.
Delta S is also positive. So what is more likely to make it spontaneous? A big temperature or a little temperature? Big temperature. That way we're subtracting a bigger number, right? You see this?
Yeah.
Because it's temperature times delta S. So the bigger number we can subtract, the more likely this is to be negative. So these will be spontaneous. At high temp. Quadrants are better than that table in your notes, and the same thing is in your book. Okay, let's think about quadrant 3. Math people like to call this. So in quadrant 3, what?
It's just funny because you talk about math people and the math teachers talk about science people.
They do?
They say they do all the work for y'all and y'all just put it all together. Like they don't.
Isn't that the funniest thing you ever heard? Delta H over here is negative.
Wait, I gotta stop it.